Welcome everyone to a new episode of DT Vector, the podcast where we explore the people, technologies, financing, and the ideas that are shaping the future of the built environment. Today's guest is Selen Ercan. She's an architect and PhD researcher at ETH Zurich, and she's a co-founder at Layered. Layered is a construction tech startup that is building autonomous robots for wall finishing. We'll dive into her journey from academia to entrepreneurship, and we'll explore how the robotics and AI will influence the way that we are building. Welcome, Selen, to DT Vector. Thank you for coming.
Thank you very much, Eugene, for the invite and for organizing this session. I'm very happy to be here. My name is Selen, and I'm an architect by training. I have specialized in the field of digital fabrication and mostly in construction technologies throughout my studies. I first studied a Bachelor of Architecture in Ankara, in my hometown in Turkey, in the Middle East Technical University, where I got a bit the first glimpse of digital design, computational design, and digital fabrication technologies through a joint master program that was offered in collaboration with TU Delft in Netherlands. And I spent 2 years in Netherlands studying this topic. Back then, this was the year 2009 to 2011. We were quite fascinated as kind of young architects studying in the school with laser cutters and 3D printers and CNC machines and all. And we were, I think, all fascinated by the potential of using digital tools, both for design and for producing, for fabricating, basically designed objects, and for prototyping, for example, our models, or also kind of making a bit like a building element or component design using these both software and hardware tools. And then when I was studying in Delft, I got to know about the chair of digital design and fabrication in ETH Zurich. Because back then Gramazio was giving a talk at TU Delft, and I saw the talk and I was very inspired by this, and because he was talking about basically using robotic arms for architectural production, basically in architectural scale, using these robotic arms. Back then, basically, he was showing a variety of their projects, basically building from brick assemblies to kind of using them in a way, creating a new realm of digital materiality in architecture. And this was, for me as a young architect, quite inspiring. And then I applied and I found myself also at ETH Zurich after my studies, working basically in the first pioneering projects of also on-site construction. This was kind of for me the first time to kind of explore and start to work in the topic of what can such machines that are normally used in manufacturing settings, in factories, for example, in assembly lines, or kind of manufacturing of high precision components, or in automotive industry, or kind of packaging, or kind of other repetitive tasks in factories. We were kind of a little bit, in a way, the first to explore also what would it mean to kind of use a bit more intelligent machines, kind of equipped with sensors and cameras, for instance, and also having the capability of moving in a work envelope larger than the work object, which would be basically like a wall or a ceiling or a beam or any kind of building element or component you could imagine. This was, for me, basically the first time that I got exposed to the idea of using mobile machines on job sites to directly try to produce building elements on spot in situ. And also this was basically a research project funded by EU Commission, and also in a way the first kind of mobile machine that was kind of conceptually explored what it can do on a job site. After the big kind of movement of 80s and 90s, mostly in Asia, in Japan, kind of trying to automate kind of the whole process fully in a bit like a building structure like a factory. So kind of moving forward from there, our approach was also to expel on human machine collaboration scenarios, as well as, for example, what you could gain if you would use such a machine in terms of the, let's say, complexity that you can gain with kind of structural kind of integrity, for example, with geometric complexity, or what kind of, for example, efficiency gains you could achieve, or what kind of material savings you could achieve by kind of using such machines which are less prone to errors, which are kind of more robust, and which are in a way addressing a bit also back then an emerging topic as a shrinking skill set of manual labor on construction sites. And this project basically was for me in a way the start of looking in this topic of in situ fabrication, where I followed this kind of vision a bit to go in the South Asian context in Singapore ETH Center, where maybe some of you know the building typology of the city and all in all kind of the whole Singaporean context is extremely, let's say, ready for exploring more of these kind of on-site automation scenarios. And it's also quite incentivized there. So I had another project, more kind of implementation oriented, more application oriented, kind of trying to address the topic of floor finishing with tiles. So we tried to look into the topic of mobile floor tiling with a mobile manipulator, a mobile machine that can work directly on the job sites, where I also gained a lot of experience more in terms of the commercialization aspects, the industry needs, and how ready the construction industry is in general for such technologies. Also closely working with industry partners, which would be the first clients in that case for this technology. More and more kind of the end users also that would be directly exposing to this technology on site. And after this experience, basically, I kind of followed a little bit my kind of interest to go back to the core research, because I also felt like there is a lot to do also still on the research and development side, and where I kind of went back to ETH Zurich to do a PhD on the topic of what I'm pursuing right now, on a spray-based printing in motion technology, also using the mobile robotic system, and trying to basically to make the surface coating process of our building structures or our infrastructure more efficient, more sustainable, and safer for humans also to work with. And this topic basically became my PhD topic, and I have finished my PhD in 2 years ago in 2023 at ETH, where basically also because of the topic and because we knew that there was like a lot of industry need and interest for it, led me kind of to spin out a startup company with the finished, in a way, PhD research. And now, since 2024, I am trying to push together with my co-founder, Elliot Sonigo, and with a great team of engineers and AI engineers, roboticists, and also digital fabrication specialists as a startup company that is trying to now make its first steps to the first of its pilot projects, and also the first implementation in real scale building structures. And the technology itself basically is mostly addressing the topic of having a mobile printer per se, in a way, a spray-based printer, a wheeled base with a robotic arm on top, and directly being able to, with the perception capabilities it has, to understand the floor plan, the building structure, and then following from that, localize itself against the building structure intelligently, and then kind of apply the surface coating, whether it's painting or insulation or plaster or any other sprayable material directly on the surfaces of the
Mhm.
building, like say the walls or ceiling or floor, for example.
We'll talk about the technology part to understand better what layered or the robots are doing. But I'm curious because from this perspective, it looks like a bold move. What inspired you to move from academic research into entrepreneurship?
I think the biggest, let's say, motivation or inspiration was the fact that we are doing a lot of, let's say, interesting and cool research in our universities, in our research institutes, but especially in the industry that we are operating in. Very little number of these research actually make it to the industry and get really applied, basically transforming our market or industry. So for me and for kind of many people that I work with, this is, I think, a bit of a big concern becoming more and more obvious within ourselves, because we would like to actually see more of the results of our research in our industry and start actually really this digital transformation in this conventional and very strict industry, and basically see that the research results are kind of actually getting implemented and getting its kind of the good positive impacts for the use cases. I think this was for me the biggest inspiration or the biggest motivation to push it forward as a startup company from academia.
Mhm. So it's easier to implement the project from this perspective than okay, it's a research and I, somebody puts that away and maybe at one point will use that or not. It's more about implementation. I'm getting that right.
Mhm. Yes, I think so. I think really I would say the big wish to get it, also see it get implemented and see it basically get adopted, especially, for example, by the craftspeople working on job sites, and kind of also because we come up with the motivation of making the process safer for people, more sustainable for our world, and also kind of to make the process more efficient, because we know that actually the technology is there to be kind of also applied to construction. But
Mhm.
yeah, and not being there is basically maybe the biggest, say, concern and like the push, the driver behind this vision. Yeah.
And I'm curious how did the technology transfer from the university to the startup was done, and also and maybe are two layers here, but one is how the technology transfer and how the, let's say, financing financing part was covered.
For the technology transfer part, actually, the procedures are quite clear, especially in the university that we are affiliated with. It's basically, I have to say, there is a lot of support also to push startups from academia to industry and to kind of to its use in the market. And as a layered, we are still in the process of doing this, because we are now in the bridging phase from the academia to kind of becoming a fully independent company. And for the financing, I think there's in the ecosystem that we are operating, there's also great instruments addressing different stages that you are at. For example, if you are like in early research phase, there are certain agencies and kind of certain tools that you can tap into, especially in Switzerland, like the SNSF or InnoSwiss, for example, if you are more closer to its industrial application. And at the same time, when you're a bit further away, kind of becoming more of an independent startup, there's a lot of startup accelerators and support also that either from the university or from more independent bodies to kind of help you guide a little bit in this process and to kind of, in a way, get ready a little bit to the real investors, the real investors world of, for example, VCs or kind of angel investors or other sources of investment in a way. So I think the phase where the research is funded is very well organized and very well networked in Switzerland, especially. And also the part where it's kind of becoming more of, let's say, a private investment is also very well organized, not only by the university, but different, let's say, formations of, for example, like Venture Kick or Startup Campus, or as well as Switzerland Innovation Park, and kind of a mix of different foundations and also this startup accelerator. So there are I would say a variety of tools to support this process here. Yeah.
It's great to hear that, and maybe these examples can be copied more. I don't know the western part of Europe, but in eastern for sure we need more on that in the universities to have a, let's say, a support for the actually the economic, for the economy. That's, and I'm putting that right. Okay, getting back maybe more to the technology part, how the robot or the robots, how are they are looking today, and what they're actually doing on site.
So at the moment, we have our second prototype since the start of our project, basically meaning the second iteration of our prototypical development. And what it can do technologically is basically being autonomously operating on a floor plan on a construction site with certain supervision or guidance from the operator before the process would start. Basically, our technology is built on autonomous robotics, sensing systems, and also basically certain intelligence that you need in this process for control, and also a robust process, a fabrication process, as well as we are trying to push a lot a learning-based approach and AI technologies to kind of optimize the kind of, for example, the material usage or optimize the quality that we can achieve in this process. And apart from that, we are heavily caring about the interaction of this machine with the user on site. So we also invest quite a lot of effort in developing, for example, an interface that you can use as easy as on your iPhone, and can give basically the opportunity to the user to have an extended reality interface to firstly, for example, interact with the machine, for example, show the first walls the machine should start from in the room, and also kind of provide a guidance to the user whether the whole system is correctly set up. For example, if the pump is correctly connected, or if the robotic components are all kind of mounted on the arm, and for example, if the machine is all kind of ready to start spraying, for instance, and all these sorts of guidance that are needed in the process. So therefore, basically, our machine basically is capable of working with any kind of sprayable material, as I was mentioning. And we want to have the vision, basically, to have the fact that it can also scale up. So let's say it can provide at the moment the surface coating on the building structure, whether it's a painting or insulation or plaster, but at the same time, we want to also address in the future any kind of shot creating application, for example, that you could apply on a tunnel or also on heights, for example. If you would like to take this machine on a facade and kind of address the, for example, repair or even insulation of a facade structure, we would like to address that as well, because our technology is mostly on the development of the digital fabrication process and software development, in addition to hardware interfaces. But I have to say our software is hardware agnostic, which means that at the moment, we are using a wheeled mobile manipulator, but this doesn't mean that, for example, if the need would be, we wouldn't be able to, for example, use a legged robotic system, for example, or a flying machine, or any other robot morphology that would be needed in the process. Obviously, we would need time to make the necessary adjustments and tuning and everything, but we are not basically developing one machine that is used for one task, but we really want to, continue developing our core competence on the digital fabrication process, the control, and also the optimization process by a learning-based approach, basically our model development.
So it's it's what you develop. It's more on the softer side, okay. And okay, for one job, what is the, let's say, the human's job, and what is the robot's job?
For example, if you would kind of imagine taking this machine to a job site as kind of from the start of the process, obviously the humans, we imagine one person, one machine concept for the whole work cycle as like the ideal case. I mean, currently, since we are in the prototyping stage, obviously we need more than one person at the moment. But the human's task is mostly kind of starts with the logistics a bit, because you would need to basically take this machine on site firstly. But the good thing is that our robotic system is modular. So we actually remove the dependency, for example, on a crane on the construction site, because it can be kind of disassembled into three different modules, being the arm, the kind of the middle axis, and like the wheel base. And each one of them basically could be packed in the back of a van and then taken to the construction site and then assembled again, and then kind of with the remote control moved to the building unit or to the lift, go up in the necessary level, and then basically go into the room that needs to be coated. So humans' job basically is kind of mostly in this planning and the logistics side. And after the machine would be successfully connected, for example, either to the silo system or the pumping setup that you would normally have on construction site, because we designed the hardware interfaces to be compatible with any kind of pump or silo system, like mixing and pumping system that you would find on the construction site. And the human operator needs to establish that connection as well. And after the machine would be fully assembled and connected, once you would basically select your surfaces in the room, and then with this XR interface, generate basically your robotic trajectories. You would start the process, and then the human would basically transition into a supervision role, which means that overseeing the process, if something would go wrong, that the robot cannot basically come back from this failure mode, then the human would need to intervene and basically have the process continue it. But the biggest basically say shift is from the strenuous part of the job, which is the spraying and kind of also kind of finishing the walls of the structure, is done by the machine in a way. So once the machine would start working, the human can basically not do any more physical work, but kind of supervise and control a bit the process.
Mhm. And does it learn from a job to another?
Actually, yes, because of our approach of adopting a learning-based system for each time optimizing the process better. Our idea and our kind of work dynamic so far has been that we collect data. Each time, basically, we would, for example, spray a wall, a surface, we would scan, as we would say, the finished surface after spraying. And then we would associate that depth images with the fabrication, like the process parameters that are used, so that we would create, in a way, each time we spray more data sets that we can train our model with. So in a way, I can say yes, each time the robotic system would learn a bit more, because each time we would kind of go to a new site or a new project, or even in our construction lab that we have now with our startup company, each time we would spray, we yes, collect data and use the new data set to train our model more for optimization, basically.
Mhm. You've already run two pilot projects. What type of projects were this, and let's say what were the biggest challenges?
Yes, we have taken our robotic system to two pilot projects so far in the summer period, and these were housing projects that are new constructions in Switzerland. And basically, the goal was to apply in both projects what we call the base coat plastering. Most of the time, it's basically a mix of cement and lime, especially in our region. And basically, our goal in this pilot project was to firstly look at the KPIs, meaning that how much time we would spend, how much material we would spend, and like how also the machine is kind of perceived by the users. This is kind of most of the time the most valuable data that you can collect, because you never get this when you're in your lab, because you don't get exposed to the end users. And in terms of basically all of these learnings and experiences, it was an extremely valuable and successful trial for us. Because, I mean, firstly, you start, when you go for your first pilot trial, you expect with the a kind of lower expectation of whether you are going to succeed or not, I mean, even if the machine is going to break down, or you are going to kind of crash a couple of tools or end effectors, or when is the next cable is going to break and then the operation will be cut, for example. So in that regard, actually, it was quite a successful two pilot trials, because we managed to kind of reach the number of rooms, for example, that we wanted to finish. And but obviously this comes with a lot of challenges also that you face, which basically firstly comes mostly from the side of you take your machine first time outside your lab, which is kind of your safe zone in a way, to a completely new environment, full of obstacles that you cannot think about in your lab. Let's say the dirt or the cables or kind of holes on the wall that no one knows where it's coming from, because it's kind of like some different subcontractors are kind of doing different parts of the job. And you have to be always prepared for these kind of things. And also, each project uses, for example, a different formulation of material from time to time. And we have to always be ready also for the physical properties of these materials, because, for example, if you would have a big change in humidity or temperature, or even kind of in your spray time, sometimes you have to be quick in adapting into these. And for that, also, I think we managed quite well to address these challenges and on the spot or on the fly kind of make adaptations for this. And there's also certain challenges more on the kind of usability side, because when you want to pilot try a technology, you have to remember that this is a real project with a lot of time pressure to finish tasks. And most of the time, the people see you more like kind of like an obstacle on their timeline, because you have to come in and then kind of make a trial, and then you have to still make sure that these people finish the task necessary on a given and targeted timeline. So there's a lot of kind of things that you have to take care and kind of be aware of, because it's kind of like a real project, and it's kind of real people working on site. So I think those challenges are also not to be underestimated. And if you have a good communication, I would say, with the end users, then it's like win-win situation, because you learn a lot from their feedback of what could be done a bit different for the next time. For example, if you would like to kind of let's say, have a different logic of finishing the corners or edges. These are really valuable exchanges that you have with the people, with the craftspeople on site, because you learn about the details on the on site. And but if it becomes, let's say, more of let's say, a big unexpected time loss conception for them, then you have a big wall that you cannot talk with, and then you have to finish your job and leave the site immediately. So I think, yeah, these three categories, I would say, were kind of the most obvious challenges, being from the technical, let's say, more from the robotic side, and the material, and more the human level, anyway.
And at the human level, what was the, let's say, most common reaction of humans, of other humans, on seeing the robot? What did they ask, and how they perceived this solution?
I think it's always a mix, and we also try to kind of a little bit understand the logic of this nowadays, because we are heavily interested to understand the profile of the end users also, because I mean the fact that we are also trying to make the solution for people at the same time, and it's one of the biggest let's say motivations of us. And the when you look at more towards the, let's say, with the younger generation of craftspeople on site, you see that basically more familiarity with kind of digital tools helps a lot, obviously, because people who also are now employed with construction jobs, especially the young generation, I think they have really less and less interest in more kind of physical tasks, but more in kind of a bit in the gamification of things, which means that they can use a gadget to kind of do the task also on site. And then this becomes more like a kind of like interesting instrument or interesting tool for them as well. And but the biggest question of basically what people most ask, that this robot is going to steal my job. I think this question is not there. We don't receive this question, actually, not so much, because to my observation, people are also not so unhappy to have like a coworker that would do the strenuous, the physical part of the job, and they become more like the operator or the supervisor of the thing. And especially in our region, there is a big shortage of skilled labor becoming more and more obvious. So people are actually seeing the potential, I would say, that this machine in the near future, when it's operating, I mean, multiple machines on site, people see the potential that it will also address this kind of diminishing labor pool in construction. I know this is not the case all over the world, but especially in the DACH region, in Europe, this is becoming an obvious problem, as we see also from EU policies in kind of funding instruments, and how can you reduce dependency on manual labor on construction sites. And also the fact that, I mean, safety is becoming an obvious urgent topic. I mean, construction is not one of the safest industries in the world. And apart from that, there is also, I would say, the curious profile, which want to learn about the system and the technology more and more. And they are kind of also the profile which would give you the most feedback in terms of what could be improved to make it a bit more adaptable, a bit more usable in a case. And these are kind of, I would say, more the master surface coaters or plasterers who have spent a lot of years in the industry, and who are kind of also interested to contribute in the future technologies of their craft in a way. And maybe, yeah, there is also a lot of skeptical craftspeople on site that you find, because uh, you have to also be careful about filtering the information that you're hearing, because many people are interested, for example, to save some time, and many people are interested to also save some money. but you have to be, I think, a little bit careful there, kind of in terms of understanding the reasons of this in a way. Because if it is would be coming, for example, from the subcontractor, the business owner, obviously, like the concern will be also to save some time and some resources, like some money. But you have to be careful. These people will not be kind of the ones using the machine on site, because they will be also again hiring the people who will be using the machine. So we want to actually hear more from the people who are kind of working with the machine, more on the on-site people, in addition to the business owners. So yeah, I think it's quite heterogeneous on site, the feedback that you receive. But I have to say, when the robot is on site, you have visitors every 10 minutes, like coming from different parts of the project, because it's not like everyday business to see a robotic system working on a job site. So people are very curious to see the potentials of where it is and is it really functioning, for example, and everything. And
Yeah, we can say right now that the humans are getting the robot on site, are putting the robot to work, and after that, interacting a lot with other stakeholders on site to explain and get feedback. For sure, there are more, but I only can imagine that it's a lot of curiosity there, and yeah, we'll have to see depending on what their each stakeholder is getting from this process. They will have, let's say, a valuable feedback for you probably.
yeah,
Maybe we can speak a little bit more about the efficiency and the impact that this solution is having, or you maybe have a roadmap of improvements. Tell us a little bit about what you're achieving right now and what you are looking for in the future.
sure. So exactly, like when we talk about basically our, let's say, key performance indicators, we talk a lot about efficiency in terms of exactly the time that you spend to finish a square meter, and also to a really great extent, basically, if possible, how much you can lower the material usage, for instance, and also how robust and consistent you can provide the necessary quality, because that's also a big part of the efficiency. If you don't have to repeat the job over and over to kind of overcome mistakes or certain quality defects, for example. At the moment, with our current setup, I mean, if apart from basically the state being a prototype, and basically we need a larger amount of time for setup, for example, once the machine basically would be functional, we can increase the time that you would spend to finish a surface, even now up to 2 times faster. And this is basically our, let's say, initial benchmark. But obviously, we see that in 1 year time, we can increase this number immensely, because we will be kind of having another iteration of the system with lots of improvements, and we can kind of address with more and more on-site trials the challenges that we are facing. The topic for us basically is that we want to see this process as a whole, from the start basically of entering the construction site, from the setup to kind of generating the tool, like the robot trajectories, to starting to spray. We want to kind of make improvements in every step of this process. So we are now in the cycle of an analysis of how much time we spend in each process. And then we are trying to understand what improvements can be made both on the software and on the hardware improvement side. Because our process is basically, as I was explaining, is a spray-based robotic technology. Even though we have some developments also for example, smoothing or some contact-based applications that you would need to, for example, make the sprayed plaster smoother or flat. We are at the moment moving along the concept of basically the robot spraying in a much better quality and a spray structure than the human, and then kind of human spending less time and less effort to using a trowel to flatten it, for example, because we believe that this is a lower hanging fruit to come out to the market, that this kind of building on both competences of the robot and the human, and then kind of in a further iteration of the company, also to look at the automation of certain smoothing or kind of trolling tools with the mobile manipulators. So because we have some development there, but we don't want to push it as kind of like I don't know, a bigger research and development and then go to the market on a later stage. We would like to go to the market with this concept and then develop a bit further automation steps later. Because if we think that if we don't start using this machine as early as possible, it will never reach that basic learning process as we have now, staying in the lab, I mean. So basically, we would like to understand also a little bit better um, what does it mean for example, each different profile of our clients in terms of quality and speed requirements, for example, and then fine tune it accordingly. Because you can, for example, go much faster with the spraying process, more than 2 times faster, but then you have to sacrifice a little bit from the spray quality because you can have a bit of a rougher surface with a faster process speed, but maybe sometimes your client is actually happy with that result because they only care about the speed, but they don't, because there are different grades of qualities in surface finishing as from, let's say, Q1 to Q3, and some clients are kind of only interested in receiving Q2 quality, but with a higher speed of the process. So we want to actually analyze this more and then come up with, let's say, a better proposal in each project. And for this, basically, we would like to kind of make one, maybe a couple of more iterations for hardware and software as well. The thing is basically, we would like to basically also understand how we can kind of eliminate the steps of that are normally done, because sometimes you need, I don't know, 7 steps or 7 tools in certain surface coatings, which is extremely time consuming and also physically like needy for humans. So if we want to also understand, if you would do this process robotically, how many steps you can eliminate because of the consistent, let's say, a better quality of spray. You can basically eliminate certain steps, and how much basically efficiency you can gain from there for kind of a better, a robust kind of a spray result. So there are kind of different aspects of basically reaching our goals, but as far as we can basically operate, basically not much cheaper, but in a similar price range of certain standards, but obviously faster and more sustainable and safer way of operating. We see that this is creating a really good traction in the market.
Yeah, for sure. If we're looking at the material waste, that is such a big issue, or health and safety working on site, for sure, that are numbers that can be improved on how the, let's say, things happen right now on the construction sites, for sure. Let's talk a little bit about market adoption and maybe more on the feedback part. And I was wondering when you were explaining about the technology and about the interaction with the clients, what happens if, let's say, tomorrow or this week, 100 clients came to the door and say, I want that. I want this solution on my site. I want to use that. What happens? What are you doing?
Yeah, well, this would be really good news for us, because maybe not so good, because we have actually quite a lot of ideas to pilot, but not enough at the moment, let's say, the team capacity to push more projects. Because at the same time, I have to say, construction is a very interesting industry where you have actually a lot of a large actually client base in terms of end users, but it's not like a bit like an industry that you would find, for example, in luxury products, that there's a really high margin. It's like you can do 100 projects or 1,000 projects, but since the margins and like the costs of projects are not very high, you cannot, unfortunately, only sustain or kind of fund yourself with this kind of 100 clients that you would have. Basically, especially if you're a startup company, that you are trying to develop a new technology, as we see in many other examples, you need kind of, let's say, the big push in terms of resource, in terms of finances, to extend your team to a certain scale, and also extend your hardware base to a certain scale. And you need to maintain those machines. You need to basically find the right, let's say, dynamics to kind of operate and kind of be responsible of those machines working in different parts of the country or the world, basically. So for this, let's say it would be still kind of, I think, an interesting situation for us, because we would, for example, find, I think, um, a way to kind of convince these adopters to kind of work with us, and at the same time kind of help us push and finance this kind of technology into the market. But I have to say, still, the biggest challenge would be to find the right balance between this, what kind of capital you need to sustain a hardware and software heavy startup, and also at the same time in an industry where the contractors would not pay more than 5,000 or even maybe maximum 20,000 for a machine, you know. It's kind of, let's say, you are trying to bring an intelligent system, by the way, which is not that expensive as compared to other robotics systems that you find in other industries, but at the same time, still a bit of a high margin technology to an industry which is not very high margin, and which basically the client base is not very capital heavy. So this is kind of a little bit of creating sometimes some challenges and conflicts for you, because then you have to find more creative ways to, let's say, sustain your life as a startup company. And many people tell you that basically the numbers are clear, you basically have a certain limit in scaling up and all, but actually we honestly don't really so much believe in that. We really think that this has a big potential to kind of digitize and scale up in our industry, because even with the first feedback that we receive, we see that more and more people use this. Actually, the value that you can create with this is going to amplify, because of the fact that we will see this transition of this profile change, I think, in construction also very soon. And in terms of basically not only in Europe, but in other parts of the world, basically people are not doing the physical part of the job, but more kind of a bit like an edit, like a digital agent, kind of trying to kind of supervise things. And also this will create hopefully a bigger, let's say, margin, a bigger value for actually the construction work also. And I think this will come more like a kind of like in tandem cycle, that we will be able to kind of, let's say, have the right margins for our pilot projects, of our real project, real implementations, and also kind of be able to address 100 clients at the same time and have a scaled up business in a way. But still, as of today, I would say the importance, I think, of more like construction focused or kind of prop tech or contact focused investment is quite vital, because without that, you are only ending up with kind of more country specific, state specific incentives, which is more top down, and which sometimes might help, but I think the real key, I think, would be to kind of this goes a bit hand in hand with private investment and with public investment.
Um, For now, let's say from what I'm seeing, the business model is okay. It's you're a service provider because you have the software, you have the hardware, and you're delivering a work on a construction site. How do you see that changing in the future?
Um, we at the moment basically has set our business model basically as the concept of selling our service, which means that basically, I mean, not like a plastering company, but because we are a new profile, we are a construction robotics company that would basically provide the service, for example, to a subcontractor or a general contractor in the field, basically, for example, selling per square meter certain services of finishing the surfaces, the walls of the building structure, for instance. And we imagine basically more or less like a rollout strategy that once this model would be more established, basically more we have kind of more adopters that are kind of using our service, we think that people will be more familiar with the system. And the more familiar they will become with the system, actually, people would be kind of actually, in a way, training each other because the kind of the machine will be hopefully will be on more job sites and people will see it and use it more and more, and they will actually will know in a way the machine better. So maybe at one point our team will not be necessary as the operators, and then we can then imagine that at that stage we imagine to go on the stage of selling the system directly to contractors, so it can be used directly by the people that are buying the machine. And we imagine that possibly this stage will come in a couple of years after we establish the model of selling the service as layered. Also having the operators directly hired by our company and going from job site to job site, kind of finishing the square meters necessary on the site.
Mhm. Is there any competition? Okay, I know it's a niche, but probably there are projects similar in the world that combines similar solutions for the construction industry. Do you know some of them, and what are they're doing or their challenges?
Yeah, I mean, this topic of basically using a mobile robots on site to kind of address surface finishing has been a popular topic also in different parts of the world, even though we think this existing technologies that are out there also, whether if it's a startup or more like an early stage research and development effort, is not very, very similar to what we are doing because of the fact that basically we, firstly, I mean, some of these companies basically come purely from the application side and not from the research domain. I think that maybe one of the first differences that we have is that we actually come from a background of a bit like 4 to 5 years of the research period in a university, and then coming as with like a more kind of visionary kind of researchers trying to kind of push this technology out in a way as a kind of a difference to some of these existing technologies. And also the fact that we are not, for example, focusing only on one type of finishing, which you see in most of these companies, whether you see a lot of, for example, painting robots out there, which can only do painting, or you see basically some robots that are kind of only focused on a certain renderings, which they can do only that type of stuff, because when you kind of focus only on one type of application, you also kind of build necessary auxiliaries and components as well as part of the machine, whether it's like a pump, for example, that you would need to paint spray on, or kind of other components. Whereas basically we see ourselves a bit more of kind of this, as I was saying, this hardware agnostic kind of a system developer who can kind of address different types of surfaces, different types of surface coating, and also actually investing a lot of time and effort also on the technology development in terms of, for example, using AI-based tools and also extended reality interface and also more of a more sophisticated control approach that would enable this machine to kind of, what we say, print in motion. And I don't know at the moment another company or an effort that would, like they say, equally kind of research and kind of invest in this kind of technological developments, but more on kind of maybe a simpler robotic setup and kind of, let's say, um, a simpler kind of a control system that would allow the machine kind of to do one type of surface and one type of surface finishing, which is the most dominant in that market. So our approach is, I would say, quite different in that regard. And I think our biggest competitor at the moment that we always kind of benchmark ourselves is actually the manual work, because we don't have kind of a machine or kind of a system that is able to do what we are doing at the moment. And that's for that reason, actually, we cannot take some benchmarking numbers from an existing another technology, but we take our benchmark numbers, for example, from the manual work for that reason, because most of the systems that you, for example, if you look at a bit to Asia, the systems that you find are also for base coat plastering, that are machines that are semi-automated or kind of even manual machines, or machines that can be basically used to apply as kind of a plaster-based product, a cementitious product with less details resolved, not with the quality that you expect that as a construction quality in Europe, for example. And that's basically then kind of opening up the big question of you are not really at the same stage as the technology development. Therefore, basically, we can say that, yeah, we don't know any other company currently who can basically do the same type of this kind of mobile spray-based printing in motion, and at the same time optimize the process for different type of surfaces, whether it's a brick wall or a concrete wall or a dry wall or a stone wall, for example, and apply any kind of sprayable material.
Mhm. And what's your take on projects like the ones that Elon Musk is developing or Boston Dynamics? Do you see some synergies there? Maybe I don't know if it's any competition or inspiration for the construction sector.
I am not super familiar with the construction related projects of Elon Musk, but
Not
the
construction. What's developing in the robot space? Maybe not for construction. I'm
yeah, and a bit, but exactly the legged robotics domain is really interesting for us actually. I mean, the for us actually the the real interesting part is that as long as, because we are heavily like focusing on the construction sector, and these basically machines that are being developed heavily nowadays, whether it's like a flying machine or a legged robot, if it could make sense, if it's reasonable for the application that we are targeting and for the objective that we are targeting, I mean, we would be very excited actually to jump on a new kind of morphology and like a legged robot, or I cannot say humanoid because I really don't see the connection so much to construction. We can jump on this basically and try to actually explore also the possibilities there. And for me, like the biggest, let's say, relevance so far with, especially with legged robots or with quadricopters, is obviously surveying. And for example, monitoring the progress tracking or monitoring, for instance, and maybe more developments will come to make such machines also a bit more stable in terms of state and in terms of kind of operating on site. And then we can also start looking at that. It's just that for the application that we are targeting currently, this wheeled mobile manipulator morphology we are using is what we kind of need and what we can achieve our target in a way. And I'm saying this because of the fact that with spraying tasks, especially, you need a lot of stability and precision in terms of keeping, for example, your target pose in space in reference to a wall structure, for instance, which is a bit more difficult with, for example, machines such as quadrocopters, which need to move all the time for estimating the state, for example, or with legged machines, for instance. And because of this precision need and because of the stability need, we look for more this wheeled robots at the moment. But obviously, we follow, especially Boston Dynamics or in robotics, or like say what is happening, especially in the Zurich robotics ecosystem closely. I mean, we are also kind of part of this network, and we always are really eager to kind of let's say uh, find out the possibilities of these developments in construction all the time. Yeah, I mean,
Yeah.
I have to also say that Zurich is becoming a big hotspot for this because of the all of the startups and developments happening in robotics and AI in Central Europe.
That's great. And I love that you've talked about precision because from, let's say, we're doing a lot of land surveying and stakeouts on construction site, and we know what difference makes the precision and why do we need it in construction. So yeah, I like that you mentioned that. Before we wrap up, I have two more questions. 10 years from now, what legacy would you like Laird to have in the construction industry?
Well, when I'm asked this question, I always first say that basically we want to be able to kind of reach our goal, to say that we made it in terms of basically at least from a point starting this transition towards more digitalization in the construction industry and to become this established automation technology that is used, adopted, and kind of scaled up in the sector. So we don't imagine basically a direct, let's say, exit strategy before we could reach our goals in terms of being, let's say, this successful implemented technology, also changing a bit the dynamics on site towards the more automation on the job site. So I think 10 years from now, we want to be the company, we want to be the startup, firstly, to say that, yes, we have 50 machines operating in different parts of the world, and basically we are fully operational and fully kind of scaled up in terms of also maybe different applications as well. So we don't purely come from a motivation of a financial success. Obviously, it is the biggest, let's say, success, a key indicator of success as well. But since we come also more from the background of innovation and research, we really want to actually see the results both financially and also technologically, I think, in our industry.
Mhm. And finally, if you could recommend one person we should invite on our podcast, who would it be and why?
I have to wait, think about it. I think I will I will recommend my colleague and friend as well, who is also a big innovator, also in the construction industry, Romana Rust, who is also a co-founder of a construction startup, mostly working in the field of data and BIM. And they have also a startup company, a Zurich-based startup company called Vision, and she's a great innovator. She's a great designer and also a thinker. So I would say she would be giving you more perspective also from the multimodal data exchanges and kind of the project data flows from site to the office and other aspects of what is happening in the scene, more from basically the architectural design and kind of more from the perspective of, let's say, building, let's say, uh, management, execution, and design perspective. So I think maybe she would be a great guest to have also in this podcast series.
That's great. Thank you for the recommendation. And really big thank you, Helen, for coming to the podcast and sharing your vision about robotics, about software, and about how those both can change an industry. To our listeners, if you enjoyed the podcast, you know what you have to do to like it, share it to other guys from real estate, from the construction industry, because we're trying to tell some really cool stories that can change this environment. Until next time, I'm Eugen Ursu. This is Data Vector, the platform that is connecting the dots of the built world. Thank you once again, Selen, for coming to our podcast.
Thank you very much, Eugene.
Thank you. Bye bye.